All right, good evening. It's not a Sunday afternoon. My name is Jeff. I'm a woodturner from St. Louis. I've been a member of this club for a number of years, and I've missed the last, 2 years, 3 years worth of meetings, except for the one time that I showed up and the building was still locked, so we had the meeting in the parking lot. Better. Can you hear me? Can you hear me now? Can you hear me now? Can you hear me now? All right. Anyway, so yeah, I'm really happy that we're not outside, although I think it's about as hot as it was that particular Sunday afternoon. We're going to be doing hand-chased threaded nut and bolts. Hand-chased threaded nuts and bolts. This is a project that I actually started doing a couple of years ago because Larry Randolph and in the Springfield, Missouri club forced me to figure it out. And yeah, if you know Larry, I probably don't need to explain any more than that. But it was a really interesting process, and I've kind of made it one of my new current things. And if you can learn how to do thread chasing on a project like this, then you can learn how to do thread chasing on any type of project. Now I'm going to take a half step back. I want to talk about myself for just a minute because I've got some really cool news that I haven't bragged about locally much. But I am currently the very first and the very only American woodturner that has been accepted into the Register of Professional Turners. This is a British organization full of mostly full-time woodturners. They promote quality and excellence in woodturning. It is a very prestigious organization. I still don't know why they allowed me to join. Before you say anything, Steve, I don't know why they let me in, but they let me in, and it's been a really cool thing. The United States does not have any organization that assesses and vets woodturning skill. That people say, well, how many professional woodturners do we have? Well, anybody that wants to can put their hand up, whether you make money at it or not. But there's no system in America that assesses our skill set to any degree at all. The Brits have something set up, and they have had because that's what they do. They assess skills. They've been doing that for centuries upon centuries, and they're trying to start expanding their membership to bring in some non-English members. They've got one Canadian now. They have one American, and it's me. So it just I like talking about that. If you have any interest in trying to prove your worth and your skill level and whatever, if you want to become a member of the RPT, go to the Register of Professional Woodturners website, or Register of Professional Turners website. There is an enormous amount of information there. The assessment process was no joke. I was very nervous, very concerned that I was not going to be allowed in after my first go. The assessment process for people that do not live in England has to be virtual. So in addition to everything else, you have to have the ability to do a reasonable live virtual testing from your own shop, and that gets a little complicated too. Fortunately for me, I've already got the recording and the broadcasting thing under control. So I had a little bit of an advantage, but just something to think about. It's a neat organization. It's a neat way to provide legitimacy to your own skill set for you, for your potential customers, for places where you might teach, and it just sounds really cool, and you get a neat badge and a cool pin, and there you go. Anyway, all right, so as far as the demonstration goes, we're going to do some hand chase threading. This, like most of the things in wood turning, is not difficult. It's technical, and those are not the same thing. Okay, just because it's technical or slightly complicated does not mean it's hard. It's not a hard process. It's a very technical process. You have to have a lathe that runs at a very low speed. You have to have a little bit of rhythm. Ken, you're out. I've seen you dance. It's not going to work. You have to have a little bit of rhythm. You have to understand the process. You have to have a very light touch, and you have to practice a lot, just like everything else. But it's not hard. It's not difficult. I like saying that up front because people say, "Well, I can't do that." Well, there's lots of things that I said I couldn't do that I turned around and actually found out that I really could do them, and that's been a tremendous experience as well. Just because it's complicated doesn't mean it's difficult. I'm going to go over pretty much the basics of the entire process. We'll talk about your lathe capabilities, types of woods that are appropriate. I'll talk specifically about the tools. I'll go ahead and hammer through a good portion of a project, and I'll try to get it all done in an hour and 10 minutes. So here we go. All right, so hand chase threading. You need to have a lathe that runs at a reasonably low rate of speed, a low RPM, a low miles per hour. Realistically, on this type of machine, a Powermatic 3520B, which I have one of these myself, I like this machine to run at about 275 RPM. Okay, so some of your bench tops, some of your older machines, they simply will not be able to run slow enough. Anything over 300 to 325 RPM is going to be very hard for your hand-eye coordination to be able to deal with. It just gets moving too quickly. If you don't have a good, reasonably accurate tack on your machine, an RPM counter, there's a way that you can gauge your hand-eye reaction just by chasing the thread of your lathe spindle with your eyes. So I'm going to turn this machine on. I'm going to turn the machine on. I'm going to dial it in at my preferred speed, which is about 275, 260, 268. All right, so we're at 269 right now. And I'm going to close my right eye just because that's the farthest one away. And I'm going to try to physically chase the spindle thread with my eye from the front edge back to the shoulder. All right, and I'm gauging my reaction speed. If my eye can move fast enough to completely follow that single thread revolution from the outside edge to the shoulder, then my reaction time is probably going to be really comparable to what speed this machine is able to run. I know I can go a little bit faster, so I'm probably going to start at about 268, 269, because that's where this machine's dialed in, and I'm going to take a couple of passes. When I start chasing, probably going to increase my speed. I'll probably end up at about 300 to 310. Right, that's what normally happens, but I always start at this lower speed. Your machine must run slowly. Hand chase threads is not a fast process. It's a very slow process. And the reason is you're not chasing the thread, okay? Once you get a single thread on the surface of the material, one single 360 revolution, that's all you have to do. The rest of your experience is simply hanging onto that tool, not screwing everything up, and looking really good while you're doing it. I got the first 2 steps down. I'm still working on that looking good part, but you know, I got a couple years to go yet. I might get there. You're not chasing the thread. You're chasing the tool, because when you get that first revolution, that first 360-degree thread, the material will take the tool and drag it along, okay? It's easy for me to say this. When we get to, I'm going to try to save enough time so at the very end we can chuck up a piece of wood, and if you want, you can come over and you can feel exactly what I'm talking about. I can say lots of words, but it's better if you can pick up the tool and go, oh, that's what it feels like. Once you get that first thread, the material will pull the tool along. Your job is to chase the tool. You're not chasing the threads, you're chasing the tool. The threads will happen automatically once you get that first one done, okay? And I'll try really hard to show this to you in real time. Materials. Question?
Can you screw that up?
Oh, I can screw it up.
No pun intended. If the tool isn't at the right rotation.
Yes. Yes, so the question was, can I screw it up? And the answer is absolutely. So what he was asking is tool orientation. It needs to be dead flat on the tool rest. So if you, because the tools are manufactured in a very specific way, go overhead. Tools are manufactured in a very specific way, so I don't know if you can There, you can see that there's grooves, but they're at a slight angle, okay? Yeah, you can come up, I can see the slight angle standing here and looking at it. Looking at it on the camera, maybe not so much. So come up and check out the tools before you get out of here. But the threads have a slight angle to them, okay? So if I have the tool flat on the tool rest, those threads are at that very specific pitch. If I angle the tool up, I roll it up on one side or the other, I'm not dead flat, it will cross thread and strip out the work that you've already done. The tool must be dead flat on the tool rest. What I normally do is I normally have a much smaller tool rest with a hardened steel rod on top. It is very clean, it is very true, it is very slick, and I didn't bring it just because I forgot. We're going to use a stock Powermatic tool rest. I cleaned it up a little bit, it had a little bit of rust on it, but if there's any nicks or burrs in your tool rest, you want to sand those out or file them out. You want your tool rest to be dead flat, dead true, and we'll get into the specifics about the tool, but yes, it absolutely has to be dead flat or you're going to screw it up. But less force involved in controlling the tool is going to fix a lot of your problems, okay? And I'll talk specifically about that. Traditionally, thread chasing tools come in a matched set, a matched pair, male and female, inside, outside. They have handles. They're normally two tools in a set. And Carter & Son has come out with a Mike Mahoney design where the thread chasing tool set is one tool with male threads on one side, female threads on the other side. If I'm doing finer threads, I have to utilize my matched pairs because the Carter & Son system only comes in two coarser, more coarse pitches, a 12 and a 16 threads per inch. The classic traditional matched pairs of tools will go up to 20 TPI or 22 TPI. I think I've seen it 24 TPI, but that's really fine, and it's going to be very limiting on what materials that you can turn threads with. And when we're talking about matching the thread pitch, the TPI, versus the material, the finer the thread, the easier it is to use the tools, all right? It's not as aggressive. You have a lot more control. It is a very light touch, very light process. But because the threads are very small, you are limited to very high density woods or acrylics or things that have been properly stabilized. So if I'm using my 20 TPIs, I'm probably working on something that has a specific gravity that's very close to 1. So the ultimate wood for something like that would be lignum vitae. It's getting kind of hard to get a hold of when you can get a hold of. It's usually only in very small pieces, and I don't think you're going to want to use that to turn a threaded nut and bolt, even though I did. The cool thing about lignum vitae is it does have a specific gravity of 1. It's also a very oily wood. It's the only wood considered to be self-lubricating because of the oil content in that wood, and it makes it a really beautiful wood for thread chasing. Do not go out and spend a bunch of money on lignum vitae to practice. You're not going to be happy. You're going to get fussy with me, and I'm going to tell you that I'm going to remind you that I told you not to do that, so you can't get fussy. Other woods that would be really good, high-density woods, cocobolo, African blackwood, ebony. A lot of the rosewoods are really good. Anything in the cocobolo/rosewood family is going to be pretty good. Pay attention to the specific gravities. There's a lot of information online. As woodturners, you probably also should have a copy of the wood identification manual. It's about that thick, and it has an enormous amount of information on there. You can get specific gravities on almost everything. There's also an online version. Again, you can get that information. But the more dense the wood, the easier it will be to thread. The threads are going to be able to be created. More importantly, the threads are going to be strong enough that they're going to last having something screwed on and screwed off and screwed on and screwed off. You got to think about the durability. So if I was going to do a very fine pitch threading, I would not want to use something like a hard maple, which I find really good to practice with a coarse pitch thread chaser like we're going to do for the nut and bolt, but the threads are more likely to crumble when they're that tiny, okay? If I go to a more coarse threading pitch, like we're going to do for the nut and bolt, it's a little bit more challenging to learn the process with. It becomes more aggressive. You have to spend more time because the threads take longer to evolve and develop, which means there's more chance you're going to screw it up throughout that process. The flip side is I can put coarse threads on more materials. I don't have to rely on those more exotic, more expensive, high-density woods. So using the coarse threads on something like a hard maple, I can get away with doing threading on that a lot of the time. I want a wood that's going to be very simple grain, very straight grain, very plain. I don't want to put threads on burl. You burl guys, you don't want to thread that. I don't want to do something that's high figured. I want low figure. If I'm working with a high figured piece of wood, say for a threaded box, I might use an African blackwood insert and thread that instead of trying to thread the surrounding wood. So there's lots of things that you can do in order to get threads onto something. I could use a really good example are funeral urns, whether they're human urns or pet urns that you can buy threaded brass inserts. Well, I can take a piece of acrylic, or I can take a piece of corian or blackwood or English boxwood, and I can make an insert of myself that I hand chase the threads and put that in a material, a wood, or something that may not be as usable for that particular threading process. There's lots of things that you can do to bypass the materials that you're working with. And the easiest way for me to bypass is go full on acrylic, which is what we're going to play with today. Acrylic is ridiculously dense. It's very forgiving. I don't have to worry about it warping. It's not going to expand or contract when the seasons change, so nothing will ever change. The downside to acrylic is it's very brittle, and if I get too heavy-handed during the shaping process, I run the risk of shattering that acrylic. So that's why I went ahead and roughed down my demo piece already. I've already turned this down and put a dovetail on either end, because that's going to be the first step. Take your material, whatever your material it is, take your rectangular piece, turn it into a cylinder, put a dovetail on each end that matches the jaws on your favorite chucking system. All right, so first thing that I want to do, I've started between centers, I roughed it down, I put a dovetail on each side. I'm going to chuck it up. I need to part off the section that's going to become the nut. Get this out of the way so I don't break anything important. Whenever you're doing general turning, make sure you wear a face mask, because this is an AAW sanctioned club. I kind of have to say the words. All right, so I'm creating the illusion of a piece of hardware. That's all I'm doing. And the first step is to part off the nut section. So when I did this orange one, I parted it off the end, okay? Dovetail on each side. I'm ready to go. Make sure you do that first. It's easier than going back and trying to put a dovetail on something that should have already had one. All right. Turning speed, turn to a speed at which you're comfortable. I'm not going to tell you what speed I'm turning at because it's not important to this particular part of the process, and I have a tendency to turn at a higher rate of speed than a lot of other turners. I'm simply using a standard parting tool. I'm going for about a 3/4 inch, half inch to a 3/4 inch thick nut. The thicker it is, the more threads you have to deal with, which means the more accuracy you have to provide, which may get a little complicated. If you're practicing or you're doing this process to start with, don't make it a really thick nut. Go smaller. Keep it within your comfort level while you're learning the process. I'm not going to make it super big, because the bigger it is, the longer it takes. Just like wood, make sure that you have a relief cut, your primary part cut, followed by a relief cut. I don't want anything to get hot and jam up. And there's the downside to working with acrylic is you get to a point where you can't see anything. Now, I also want to try to slightly undercut the inside face of the nut piece simply because it makes it look a little bit more realistic. All right, just separated through. Okay, so we've parted off the nut. We're going to get the pointy part out of the way. Whew. It's still every bit as hot in here as it used to be. Okay. The bolt goes away, the nut goes into the chuck. Always, always, always thread the female threads first, okay? Just like in real life, the females dictate everything. They're the most important, and they dictate everything. No, I'm not just saying that because I'm married, my wife's not here. Some of you know how to get a hold of her, and I don't want anything reported back. That's really why I'm saying it. No, seriously, because everything we do as woodturners is removal. It's reduction. It's much easier to dial in the female threads and reduce the male threads to match than it is to do the male threads first and try to match the females through expansion. I want the most amount of precision on the female threads, and it's easier to do that first. If these are really precise, these don't have to be as precise, okay? And again, I'm technically making a fastener, but it's not really a fastener. It's the illusion of a fastener, so it doesn't have to be absolutely spot on. Now, the next thing that I want to do is I want to take a Forstner bit. I think this is an inch and 1/8. And I want to go ahead and run through. The reason why I'm using a Forstner bit instead of using a spindle gouge and then a box scraper is simply because I want the inside opening to be as straight as possible before I start messing around with it, all right? If I don't use something that's dead parallel, I run the risk of having a non-parallel opening that I have to dial in by hand. The human body is capable of complex movements, but it's not a precision machine. There's nothing that I can do to improve my level of precision. No amount of practice is going to allow me to do that. It simply isn't possible. Now, when I'm using a drill bit, especially something like a Forstner bit, I want my tailstock loose. I want to move the entire tailstock assembly up and let the Forstner bit touch. Sometimes it'll kind of wander around and then it should settle down. It'll find its own center, and that's when I want to lock the tailstock. And then I want to start advancing. Make sure your quill lock is unlocked. I'm running at 400 RPM, and I'm not advancing very quickly. Apparently I found the only sharp Forstner bit that I own because it's really cutting nicely. I'm really pleased at this. I do need to worry about heat, so I might run it in and run it out, but since I'm going all the way through, all the way through, there we go. Since I'm going all the way through, I'm not as worried about anything. Since you're going all the way through, you want a short tenon on that nut assembly, and you want to make sure that you remember that if you crank too far, your Forstner bit's going to find the inside bottom of your chuck jaws. These haven't hit the inside bottom of the chuck jaws yet. That's probably why it's still sharp. That was just a really nice experience. And then this can come out and go away. You know, use whatever size Forstner bit you think you need for whatever project that you're working on. I like 1 inch to 1 1/4 inch for a 2 inch to 2.5 inch diameter piece of material. And that seems to work very well at that size. All right, Now, there's a disc inside there. I am going to remove, get rid of the disc, and re-register. Okay, it's still running fairly true. I don't need to worry about changing anything. Next thing I want to do is I want to move my tool rest, put my tool rest in a position, cross that opening. I want the tool rest height at a height that puts the working edge of my thread chasers on spindle center, okay? But before I raise that, I want to take a different tool. I've just got a 3/8 inch beading and parting tool. I want to put about a 45-degree chamfer on the leading edge of that opening, okay? I don't ever want to start trying to chase threads on a hard corner. I want to soften the corner. About 45 degrees with a straight edge, beading and parting tool, a skew like some of you like to use. I could use a standard parting tool. I could use a spindle gouge just in a drawing motion. That whatever it takes to soften that edge up. If it's a hard intersection, it can grab and yank the tool, which will force you or cause you to jerk or lurch, which may screw things up. You'll eventually get it sorted. It just makes the beginning of the process a little bit more aggressive, which might turn you off from the process. Now, modern thread chasers, almost all of them now, are sold where they have a little bit of a dovetail on the leading edge. So you can see on that female chaser, you can see the reflection. That's actually a negative rake, all right? So it's not a straight, flat scraper. It's got a slight decline, a slight negative rake angle. Technically, this is a negative rake scraper. That's all it is. What I am doing is participating in a controlled catch. Thread chasing is nothing more than participating in a controlled catch. What happens when you get a catch? The tool skates to the left, correct? Has there, at any time in the history of wood turning, has anything else ever happened when you got a catch? No. You get a catch, tool skates to the left. That's all we're doing. The tool is catching and skating to the left. The material is taking control of the tool and drawing it to the left. That's why I say don't chase the threads, chase the tool. Once you get that first continuous revolution. Now, before I start the actual threading process, I'm going to raise my tool rest so that my tool, my negative rake edge, not the top of the tool, not this surface, but the point of that negative rake is at about spindle center when the tool is parallel to the floor. The inside threads, the female threads, I want the tool parallel to the floor the entire time, or parallel to the lathe bed. I'm going to reduce my speed to that 275-ish. All right, this one's 270. It's right at 270. I have to force the first thread. So I made that 45-degree chamfer. The tool is about 45 degrees. And I'm going to start, I will push the tool in across the surface, and then I will disengage. I am going to scribe a very small oval that happens to have one really short flat side, okay? I'm going to go straight across, disengage, out and around. Straight across, disengage, out and around. But I have to keep doing that one after another, after another, after another. That's where the rhythm comes in. And my rhythm, my body movements are 100% dependent on the speed the lathe is rotating at. Once you start practicing with this, you'll start to feel things. When you're trying to teach yourself how to thread chase, don't start by trying to learn the female. Start by trying to learn the male, because you're working on the outside of the piece. You can see everything that's going on. You can see where that little oval comes into play. You can figure out your own personal rhythm. Do I need to turn my speed up a little? Do I need to turn it back down a little? You can figure a lot of that out, and it's easier when you're looking at the threads and practicing. Once you get that part sorted, reverse your direction and start figuring out the female threads, all right? So again, I'm going to, third pass, I can feel the tool being drawn. Very loose hand. I'm not white knuckling. One or two fingers on the top, pushing down. Again, I'm not white knuckling. It's all about the movement and less about the force. All right? I do have to have my index finger on the outside of that tool in order to push the teeth back into the cut. You know, I'm working on the inside of that opening. Back in the old days of hand chasing, they had an additional armrest, they called it. It was a long tool with a long handle would tuck under your arm, and you would actually, it had a hook on it, and you would actually use that tool to apply back pressure. Modern tool steel, modern machinery have kind of rendered that tool not necessary. If you know, there's a lot of people that do use it. I find it very awkward. It gets in my way. I guess I have a little bit more rhythm, or I figured it out, or I just get really lucky a lot with this particular process. So the only force that I'm applying is with that right there. I've made one solid revolution. You're not going to be able to see it because it's acrylic goes white and dusty when it's not polished. But I felt the tool being drawn away from myself. All right. I started at 45. I started working my way inside, and then I felt when the tool started to get pulled out of my hand technically, and start advancing into that cut. So now all I have to do is keep working around as long as I am allowing the tool to move at the same speed that the threads are wanting to be developed. All right, it's actually going a little slow. I think the speed sensor on this machine is not accurate. Oh, there's the bottom of the jaws. Don't hit the bottom of the jaws with the tool. And I will keep repeating this process until I have pointy threads on the inside. When you come up and look at these tools, especially the more coarse tools, it's a very pronounced pointy series of ridges. When I get to the depth of the grooves in the tool, that's when I have a fully developed thread on the inside or on the surface that I'm working on. Right? It needs to be very defined, very well defined, the proper height based on the thread of the tool, and pointy. Okay. And when you're using the female tool, the female side of the tool, you simply want this to be in an orientation. It's like you're using a toothbrush, all right? I want those teeth parallel with the surface, and I want to work them until the threads are really nice and sharp and well defined. I'm very happy with this. Now I need to check to see if the opening is parallel, if it's wider at the mouth, or if it's narrower at their mouth. I have a very, very high precision tool. I do sell these, cash sales only. Meet me in the parking lot after the demo. If you want to go to the overhead, we'll get it's patent pending, and it's orange. A standard wooden pencil, manufactured wooden pencil, has 3 high precision pairs of matched sides, okay? This is a high precision tool. This will allow me to gauge whether or not the opening is parallel or skewed in one direction or the other. Get my tool rest out of the way. I'm going to place one of those flat sides of the pencil inside. I'm going to apply pressure with my index finger, and I'm going to lean over the bedways and sight down. Okay, so that's actually it's actually surprisingly parallel. All right, so I'm looking at the bedways, okay? These bedways are dead parallel. There is no mechanical variation here. I can sight down that pencil in line with the bedways and determine if I've got an angle one way or the other or if it's dead parallel. And if I had to change anything, I'd say maybe I need to take a hair more off on the inside. But I'm really happy. I'm not going to mess with it. We're gonna go with that. So I got it on the first try. Yay! If I needed to adjust it one way or the other, I'd simply move my tool rest back. I would dial it in with the chasers, remove a little bit at the leading edge or at the trailing edge. Again, the deeper you go, the more you need to pay attention to bottoming out on the inside. That will simply strip away everything that you've done up to that point. And effectively, the internal threads are done. All right, and I'm really happy with this. And because it's acrylic, if I need to, I can go right back into the chuck jaws. I have not removed the dovetail yet. I don't want to do that in the event that I screw something up on the other section and need to make an adjustment or need to make a completely different piece. All right, so once the nut's done, the bolt part goes into the chuck. And I did this demo for AAW. I did it in the live streaming room. And then I did it for the Carolina Mountain Woodturners. All right, that's not registered nicely. Sir. That's a good question. All right, so Steve's question is about lubrication. He asked specifically about a soapy solution, and I think no on the soapy solution, simply because that really indicates that you're starting off with water, which is going to dry, which it might be lubricating at the beginning, but it might end up being an issue later. It's got a little bit of run out. I'm going to need to true that up a little bit. The two products that I do use, I normally don't mess with them on acrylic, but I've got some Dr. Kirk Scratch Free. This comes from Craft Supplies USA out in Utah, woodturnerscatalog.com. Okay, woodturnerscatalog.com. That's where the Scratch Free comes from. This is it's technically an abrasive paste, but it's also a polish and it's also a finish. It is made with micro beads, not abrasive material in particular. This is a really good lubricant for thread chasing. I also started using Woodturners Wonders Slick Stick. Got this from Ken Rizza a couple years ago, and it works very well as well. This is really hard to apply to the female threads, so I normally just use it on the male threads on the outside. If you're going to apply a lubrication to the inside, get a toothbrush. If it's your spouse's, make sure you clean it really good before you put it back. They'll know. I don't know how they know, but they know. Just use that to apply a little bit of that lubricating material to the threads. It will improve the process. Again, on acrylic, not a big deal. Okay, I don't really need them here, but on woods, especially anything that might be affected by friction or might be a little bit more prone to crumbling, having a lubrication might make the threading process a little bit better, okay? All right, so real quick, I'm gonna grab a spindle roughing gouge. I wanna true this up just a little bit. I've got a little variation that I don't particularly like. We're gonna throw the live center back in just for kicks and giggles. Never move your tool rest when the lathe is running. All right, big thing to remind you about is when you're working with any acrylic, it's very brittle, and if you apply too much pressure into it, it will shatter. There's nothing you can do to stop that. Keep your force side to side. All right. Sometimes, quite often, utilizing a square carbide is a really good option when trying to dial things in. I'm going to see how it performs, see if it gets splintery, if I need to go back to a gouge. And the other thing that I want to do before I start really dialing anything in size-wise is I want to take a pair of vernier calipers. I don't care what the actual measurement is, that's not important. I simply want to set the calipers to the widest spot on the inside of my female threads, on the inside of the nut, and I'll give myself about an 1/8 inch more. I will reduce the size with the male chasers. I want to sneak up on the fit. All right. Normally I set it for about a 1/16 inch, and I usually get pretty good end results because of that. I want my calipers to get to a point where they're about ready to completely drop over that tenon that I'm working on, and that's when I will switch over to the thread chaser. All right. So I simply need to remove some material. I don't want to take really aggressive cuts because that's what's happened. That's what will happen with the acrylic. I want to sneak up on that. I want to not push, even though I want to push. I really want to push. All right, so somebody's going to ask, well, how do you deal with all the stupid strings that you get with acrylic? Normally, I've just got a big shop brush. While the machine's running, I'll just hold the brush. They usually don't twist up onto anything in particular. And I'll take one more pass, and then we'll stop with this nonsense and start dialing in the size. All right, so I got a little bit more to go. I want to do as much work with the tool as possible right off the bat, but I don't want to shatter anything. Okay, a little bit more. Take your time, start and stop. Take a couple of cuts, check. Take a couple of cuts, check. The closer you get before you start thread chasing, the easier, the faster the thread chasing process is going to be. And tell yourself you're simply trying to sneak up on the fit. You don't want to force this. You don't want to try to rush it, because that's where mistakes are made. And you'll have to come and talk about the mistakes that you made when you come back next month for the meeting. Didn't know that was a thing. That's new. All right, one more pass. We're almost exactly where I want to be. Also remember, the thickness of material you're removing from this side is actually doubled because it's coming off the entire piece. Okay, that's about ready to drop over. So I'm going to go ahead and get ready for chasing the male threads. Get this stuff out of the way. Okay, and I want to make a chamfer on the leading edge as well. So again, just a 45 degree. I want to get in here and I want to true up that end. There's too much material. So we're going to get the pointy bit out of the way real fast and go back in with the parting tool. Always remove the pointy bit. If you don't, you will find it with your elbow. Okay, all right, so male threads are ready to be chased. I've got a nice spigot here. I put a chamfer on the edge. I want to get my tool rest reasonably close. And I want to make a stopping point. I want to use my parting tool, something not very thick, and I want to make just a very small, very shallow parting cut. I want a visual, a physical demarcation line that tells me I need to remove the tool when I'm crossing this particular threshold, or I'm going to jam the tool into an oncoming wall of material, which is going to strip out everything that is underneath it. So I will simply, we're a little too close. I will simply use my parting tool, and I want a slight chamfer, maybe a 1/16 inch deep or so, maybe up to an 1/8 inch deep. Don't get crazy, just know that you're going to be removing material. And I simply want that to be a stopping point, all right? So, just like before, I want to dial in my speed. I was running at about 310 on this machine comfortably. Okay, we're right, 301, we're right at 301. And I'm going to start at about a 45-degree angle, you know, in alignment with that chamfer. Tool rest is too low. I lowered it for the regular turning. I want to make sure that my negative rake edge is at spindle center when the tool is parallel. Now the cool thing about chasing the male threads is I want to start with the handle either parallel or slightly below. As I raise that handle, I increase the aggressiveness of the tool, okay? I can't raise the handle of the female. The female must be dead parallel the entire time because the teeth are on the side. The teeth are on the end of the male handle. If I raise that handle, it becomes much more aggressive. So if you're beginning the process, learning the process, start with the handle down. I normally start pretty much parallel because I'm comfortable with this process. But if it seems to be a little aggressive, lower the handle, okay? Start the process, get that first groove, wait for the tool to start being drawn across the surface, then go at least to parallel. And if you're getting impatient or you want to move things along, raise it a little bit and it'll become a little bit more aggressive. But same thing, I need to create there it is. I need to create that right there. I need to create that first thread. Okay? Can they see that? Can you guys actually see the thread? Okay. All right, so there's one complete revolution on the end of this material, and that's enough for the material to start pulling the tool across. So I will place the tool on the surface. I'm pressing in, but only slightly, and every pass gets a little bit longer. I'm not trying to do the entire thing all at once. I'm not trying to make it parallel at the beginning. I'm making it kind of a cone shape. So it's a little more narrow at the tip, it's a little wider, closer to that bolt head, okay? And I don't care because I'm sneaking up on the fit. And that's really close. The only thing I'm worried about right now is getting a complete thread the entire length of the material and dialing in the actual fit at the end, okay? I'm not trying to do it all at once. I'm trying to do it in steps, in stages. Stop, check. Start, stop, check. Get the material, if you're using an acrylic, get this stuff out of the way. All right, so all I'm really trying to do, all I really want to do is get it to a point where that nut piece is starting to thread on, because that tells me, yeah, right there, all right. Okay, maybe I will be able to finish this in 15 minutes. That tells me that I am super close. And once it starts to thread on the end, now I'm going to dial in the straightness of that spigot. And I'm going to do it all with the chasing tool. I don't have to go all the way back to the end. I don't have to start at the end of the tool. I don't have to do hardly anything except continue to remove material. Stop and check, stop and check. All right, so it's threading on about a 1/4 inch worth. Now, obviously, if I was doing a small box with a very small spigot, very shallow lid section, I'd be done. You know, just zip, 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 bing, bang, boom, there you go. The longer the threading, the longer it's going to take. And you simply have to take your time. But we're getting there. Don't try to speed things up by pushing in harder, especially if you're working on an acrylic. You run the risk of ruining everything. If you're working with a wood material and the threads are crumbling, you can use thin CA to surface stabilize the threads as you go. Don't use, okay, so it's threaded all the way on. We're at the depth of the female socket. Anyway, you can use thin CA to surface stabilize your material if you need to. It's not necessary on acrylic. Don't use an accelerator if you're using CA. That has a tendency to cause it to foam. Make sure that you clean the threads out after using the CA. Almost, right? There's an 1/8 inch gap. I am almost exactly where I need to be. Huh? Yeah, I need to turn a washer. That's a different demo. Or I could turn away the threads at the very end. I just use my parting tool and turn away the threads at the very end. Parting tool, parting tool. So we're going to fix that. Because not every bolt has threads all the way up. Ta-da! All right, so we're threaded all the way on. Nut and bolt. The hard part is done. The next thing that I want to do is I want to jump back to a spindle gouge, reasonably sharp spindle gouge. Yeah. All right, that's really a good question. So Tom's question was, how long did it take for me to get proficient, or to the point where I was comfortable not only doing it, but I'd say teaching as well. He spoke to somebody else, said about 3 years. Realistically, about 3 years is probably accurate, but it depends. If you're exclusively trying to learn thread chasing on wood, that's going to be a much harder process, a much harder material to deal with, because every single piece of wood is going to be different. Almost every single piece of acrylic is going to work exactly the same. I don't have variations here. I'm not trying to work with a specific piece of material every single time I go. So, like everything, the more you practice, the better you're going to get. I really didn't start becoming proficient until Larry asked me to figure this project out and come and do a club demo. So I had a couple of months in order to do that, but that was several years ago. And now it's kind of my demo thing. Your mileage may vary. It depends on how much time you want to spend doing it. I find that doing a nut and bolt is a lot more enjoyable than doing a lidded box. These are fun. It's a fidget spinner. I've got one at my desk I can just sit and play with when I'm on a Zoom call or whatever. So the more fun you have with the process, the better everything is. In order to wrap things up, I would just use a spindle gouge. I'm not even going to do it, and turn a round surface to create the bolt head. I would part it off. I like doing a flat, because it just gives it a really nice hardware look. Okay, really super simple, easy to do. Undercut the bolt head so that if there's any irregularity, especially if it's a piece of wood or you're working with wood material, that if it moves, when it moves, because it will, you always have a good fit. Don't try to have this flat. Undercut that surface. Undercut both faces of the nut part. So I would finish turning the nut or the bolt. I would remove this from the chuck. I would put the nut back in. I would simply part off the nut. So it'll end up being a smaller diameter. And then how do you turn the round into a hex? Well, you could do math. Steve could probably do, there's probably, trigonometry or something involved in order to figure out how to draw a hexagon. Or you could take your calipers, you could measure the width of your nut piece, and you could go into your desk in the air-conditioned household and sit down and open up a Word document, a blank Word document. Go up to the top and click Insert, then click Shape, then click Hexagon, and draw a hexagon on a blank Word document. Once it's on that document, you can change the parameters, all right? Make sure if it's, say, let's just say for the sake of conversation, let's just say that was a 2-inch measurement, that I wanted the widest point of the nut to be 2 inches. Well, I would make the widest point of that hexagon on that Word document 2 inches. I'd print out a piece of paper, take a pair of scissors, cut out that little hexagon, bring it over to my round nut shape, Sharpie 6 little lines, take it over to the disc sander, zip, 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 and so on. All of a sudden I've got a hexagon, okay? I'm creating the illusion of hardware. It does not have to be of a standard size to work with a commercially made wrench. I don't care. It just needs to look the part, okay? Super simple. It's an enormous amount of fun. Thread chasing is very technical, but it's not difficult. If I can do it, anybody can. Thank you for having me come out. This brings us to the end of my demonstration. If you want to come up and talk about things, that's fine.